It is time for section 1.6, where you can probably guess what's going to happen. We're going to do some integrals. They're going to involve logarithmic and exponential functions. I ran out of room, but it's okay. Got to use some abbreviations. And specifically, we're going to start with exponential functions. Now, there's really nothing new in this video. If you remember back to that table I gave you of all those derivatives and integrals, then there's one kind of new thing. I just realized there's one kind of new thing, but it won't happen until the fourth video. For most of this, just a little review. Gives us some time to get more in depth, more comfortable with exponentials and logarithms, and more practice. Okay, so let's get into it. So we have this rule that you should have seen before. Maybe you haven't seen it very much, but should have seen it at one point, that the antiderivative of an exponential function will just be itself plus any constant. And again, remember, this is just the backwards version, that if we take the derivative of the right-hand side, we should get to the left-hand side. That's all these antiderivative formulas are. Integral of a function equaling a second thing means the derivative of that second thing equals the first thing for indefinite integrals and antiderivatives. And then similarly, we have this, that this is also itself. When we took derivatives, we had to multiply by a constant. So when we take antiderivatives, we're going to divide by that constant. And again, you could verify this using properties of derivatives for exponential functions. So we're just going to use these and do some problems. Start with example 1. We'll get some review, throwing things all together. Because that's really what a big struggle of this class can be, is a single rule can make sense. But with every additional rule, there's more and more rules to juggle. In a given problem, you're not going to necessarily know what to do. You say, okay, I know this, I know this, I know this, I know this, I know this. What do I do? So that's going to be a focus for me in all of these sections. Yes, I want to focus on this new thing, exponential and logarithmic functions with integrals. But I also want to continually remind you of strategies for what are you looking at? What do you pick out? What are you looking for in order, like problem solving strategies for these is one of the big takeaways for every section in this class. It's a very big thing with integral calculus. So find the antiderivative. There are infinitely many antiderivatives, but we will write all of them just as one with the plus c. Find the antiderivatives of the following. Y equals e to the negative x. So we know that the antiderivative of a function can be found with the indefinite integral. So the antiderivative is just going to be the indefinite integral of e to the negative x, which some of you may be able to do just, I can't snap my fingers very well with my left hand, and my right hand has a glove, so I can't snap my fingers very well either. But some of you can take the antiderivative like that. Or you can use a u substitution. Let's get some practice. So if we let u, remember our choice for u substitution is usually some sort of inside function, especially when there's a derivative of that inside function somewhere else. Here, the derivative of this inside function is -1. There isn't a -1, but we can make it work. So we get du dx is just -1. So du is just negative dx. All we have to do is say, well, two negatives multiplied by each other equal a positive, so we can add a negative. And now, this negative plus this dx, everything underlined in blue, is just du. And all that we're left with after the blue stuff becomes du is e to the negative x. And we said that negative x is the same exact thing as u. Equals means same exact thing. And now we can use the formula. The antiderivative of an exponential function in this form is just itself plus a constant. Now there's a negative in front of this, so it should technically be minus c. We have to distribute that negative, but again, it goes back to the thing earlier, that if c is any positive or negative number, then subtracting any positive or negative number is just the same as adding its opposite. So it's still just any real number, and we usually write the plus. Minus c is 100% correct. But this is convention. We'll get negative e to the u, which is negative x plus c. And remember, you can always check your answer by taking the derivative of what we have. And if we take the derivative of our final answer, we should get this, right? How do you undo anti-differentiation? By differentiating. So if we take the derivative of this box thing, we get the derivative of an exponential function is itself, but we have to use the chain rule here because it's not just an x on the inside. Multiply by the derivative of the inside, and the derivative of a constant equals 0. The negatives cancel out, and we have e to the negative x. We have undone the antiderivative by differentiating. There we go. That's how we can know our answer is correct. One more part, and then we're done with this video. Find the antiderivative of this function. Now this looks a little messier. You have a couple options. Again, what we're looking for is the antiderivative, so we're going to calculate it with an integral. Couple things to notice here. First off, we can't take the derivative individually and multiply them together. Products require special rules for derivatives and integrals. If they were added, yeah, we could do them individually, but they're not. So we have to take care of that. We don't have a lot of choices right now. We could rewrite things. We could move the e inside. That could maybe work. We have u substitutions. I think that's most of our options. Algebra simplification and u substitutions. So before trying something, think about what would a u substitution look like. This is our inside function. What's the derivative of that inside function? E to the x. This is exactly what we want out of u subs. A function on the inside where if we take the derivative of this thing, we get something that's already on the outside. That's the perfect situation. So this looks very promising to use a u sub. We'll let u be that inside function, take the derivative, and say that, okay, that means du is going to be e to the x dx, which is perfect because everything underlined in blue is e to the x times dx. Remember, it's all being multiplied. Multiplication is commutative. And that blue stuff just becomes du. What's left over? What's left over is the green stuff. And the green stuff just becomes the square root of u. And now we can use the power rule. Because again, remember that the square root of u is just u to the 1/2 power. So power rule says if you have a monomial, or not even a monomial because this is a square root. Monomial is only for positive integers, non-negative integers. Anyway, if you have a variable raised to an exponent, you can use the power rule. Add a power, divide by that new power. As long as the power is not -1. We'll remind you of why later in this section. So add 1 to the exponent. 1/2 plus 1 is 3/2. Divide by 3/2 is the same as multiplying by 2/3. Add a c. And then our final step will always be to get everything back in terms of x's. And that's our final answer. Remember, you cannot distribute this exponent. Exponents don't distribute across addition. If they were multiplied, then you could put it in. Like if it were something like ab squared, then you can square both things individually if you want. But if it's a plus b, you can't. So there's nothing else we can do with this. And again, we can check our answer by taking the derivative. We take the derivative, the power rule. The exponent comes down and cancels out. We're going to get 2/3 times 3/2. Inside stays the same. This is again the chain rule. Subtract 1 from the exponent, multiply by the derivative of the inside. The derivative of the inside is just 0 plus e to the x. And then these numbers cancel, and we do indeed get exactly what we started with. Very, very good practice to check your answers when you're taking antiderivatives. That's the video. That's the next video too. The next video is just more examples. If you want more practice, the next video is for you. If you just want to work on more problems, go ahead and start. Work on as many problems as you want. The next video doesn't really have anything new that I don't think, looking at the examples, and then just more practice. So up to you. Good luck and have fun.